In this video, we're going to discuss transformations, specifically translations. A translation is when we have a graph of some function. Let's say we have a parabola, y is equal to x squared. A translation would be if we would move this whole parabola up, like this, or if we would move the whole parabola down, like that. If we would move the parabola to the right, like that, or to the left, like that. Those are the four types of translations. We're going to start with moving up. The orange one will move on to moving down. The red one will do moving right, the green one, and moving left, the purple one. Let's start with we're moving up our graph. Let's say we have a function y is equal to f of x. So we just have some function f of x. If we want to move this function up, all we have to do is add something to it. If we add 1, we move it 1 unit up. If we add 3, we move it 3 units up. If we add 25, we move it 25 units up. So let's say we have f of x, let's say f of x is equal to x squared, and we want to move this graph 3 units up. We're going to do f of x is equal to x squared plus 3. Let's graph this to see how it looks. The blue graph is going to be f of x is equal to x squared. And the red graph is going to be f of x is equal to x squared plus 3. Then we'll do zoom 6 for zoom standard. That's the original graph, y is equal to x squared. And that's the new graph when we shifted it 3 units up. Notice that the vertex was moved 3 units up, and each point on the graph of the blue graph moved 3 units up to reach the red graph. Now let's look at if we want to move our graph down. Let's say we have y is equal to f of x. To move it down, we have to subtract something. If we want to move it 3 units down, we subtract 3. Let's use the same function. We'll graph this one in black. So y is equal to x squared minus 3, zoom 6 to graph it. That's the original y is equal to f of x, which is equal to x squared. That's x squared plus 3, that's x squared minus 3. Notice that the blue is the original, and we moved each point 3 units down to get to the black, which is y is equal to x squared minus 3. Now let's look at how we would move a graph right or left. Let's say we have the function y is equal to f of x. If we want to move this graph to the right, we have to subtract something from the x. So we would do, let's say we want to move 4 units to the right, we would do y is equal to f of x minus 4. Notice that this is different than what we did before. Over here, when we were moving up and down, we had our f of x function and we subtracted 3 from the whole f of x function. Now we are subtracting 4 from the x part of the f of x function and not from the whole thing. If we were moving this graph y is equal to f of x, if we were moving it down instead of moving it to the right, it would look like this. So this means we're moving to the right, and this means we're moving down. Let's look at that. Let's say we have y is equal to x squared. We want to move it 4 units to the right. That becomes y is equal to x minus 4 squared. This is different than if we were moving it down, because if we were moving our graph down, it would be y is equal to x squared minus 4. To move it to the right, we subtract the 4 from the x itself, not from the entire function. So let's graph this. Our original function is still going to be in blue, but when we're moving it to the right, we're going to graph it in red. So we have x minus 4 squared and zoom 6. It's the original, and that's moved 4 units to the right. Let's say we want to move to the left. We would have to add something to x. So let's say we're moving 2 units to the right. We would do y is equal to f of x plus 2. So let's say we had the function y is equal to x squared as our basic function. That's called a parent function. Then to move it 2 units to the left, we would do y is equal to x plus 2 squared. And this is different than if we were moving it 2 units up, because that would look like y is equal to x squared plus 2. So let's graph these two. Y is equal to x squared is our basic parent function, the original function with no transformations. And then we want to move to the left, so it's x plus 2 squared, zoom 6. The original. and the graph that's moved 2 units to the left. So let's just sum up what we just discussed. If you have a function and you want to move it up, you have to add some number. Let's say y is equal to f of x. Let's use c to represent some constant. You have to add c. You have to add a constant. So let's say we have the function y is equal to x squared. To move it up, we would add something, let's say 3. Let's move it up. That would be the orange graph. Let's say we want to move our graph down. We would have to subtract something from our function. Let's say with y is equal to f of x, we would have to subtract some constant from the whole function. So let's say our function was y is equal to x squared. We would have to subtract 3 from the whole function. Let's say we wanted to move our graph a few units to the right. We would have to do y is equal to f of x minus some constant. We have to subtract the constant from the x itself and not from the entire function. So let's say we have the function y is equal to x squared and we want to move it 3 units to the right. We would have to do x minus 3 squared because that subtracts the 3 just from the x, not from the entire function. And then the last thing we want to do, let's say we want to move our function to the left. Let's say we have our basic function, y is equal to f of x. We would have to add some c, some constant to the function. So let's say we have y is equal to x squared. It becomes y is equal to x plus, let's say, 3 squared.